Good morning, or is it afternoon? I don't know. I forget when I see you on a Wednesday, but anyway, hope you're all well. Here's a starter question for you. Hopefully after the live lesson and with your calculator in your hand, you should be able to answer those questions. Make sure you use the calculator rather than trying to do it manually. Pause and have a go. Okay, so your first step would have been to enter number of trials and probability of success. And then for 20, I mean, you could do that manually, but might as well use the calculator. So that's 0.1143. Less than or equal to 13. So that's everything from 0 up to and including 13. So that means our lower was 0, our upper was 13. So this is a tiny number. So I'm going to convert it. So that's 4 jumps backwards. 1, 2, 3, 4. So this is 0.0006 if I round it to 4 decimal places. And 11 to 25, but it can't be 11. So it's from 12 to 25. So my lower was 12 and my upper was 25, and that's 0.9372. Okay, that was one without a context. So second starter question, can you do this one which is in a context? Start by defining your parameters and then see if you can answer that question. Okay, so there are 10 questions in this test and the unprepared student is guessing. So true, false, 50% chance of getting it right. So those were the parameters. And the first one we could have done manually. That's the probability that x equals 10. The probability gets them all right. But I'm going to use my calculator because I need it for later. So we've got 10 trials, probability is 0.5. And sorry, what's that mean? So lower and upper 10. So that is 0.00097. So I reckon that's that. I'm just going to check that. So that's 9. 1, 2, 3, 4. 0.0009, but the next digit's a 7, so I need to round it up. So yeah, that's that. Very unlikely. Very unlikely. A pass will be awarded for 8 or more correct answers. So that is. So we're looking there for a lower of 8 and an upper of 10. And that was 0.0547. A lower of 8 and an upper of 10. So I did both of those on the calculator. Note again, this was I mentioned this in the live lesson. This is one of those questions where there is no mention of binomial, so you've got to work out that it's a binomial question. Okay, one more to try before we do something new. So this first part here is about saying, right, yeah, the number of chairs can be modelled as a binomial with n and p. Look at this one again. I would use my calculator. So this was my answer to part A. 10 chairs, 15% of them are green. So I entered those parameters on my calculator. 10 and 0.15. At least 5. So 5 is the smallest, and that could be anything up to 10. So I did lower and upper 5 and 10. So that's another one in standard form. So I've got to jump the decimal place 3 places. So that's 0.0098, but the next digit's a 7, so that's 0.0099. And then exactly 2, just upper and lower, both 2. 0.2759 when rounded. Okay, right, let's talk about something new. So remember, the binomial is a special case of a probability distribution. So if I'm doing something 10 times, and every time I do it, the chance I win is 0.5, I might win no times, or I might win 10 times, or any value in between. And last week, when we first introduced probability distributions, we were displaying them in a table, etc., etc., etc. But you could also display those probabilities on a graph. And in fact, this is the graph of binomial probabilities for something that you're doing 10 times, and every time you do it, your success probability is 0.5. If 0 and 10 do actually have a probability, they're just so small it doesn't show on this graph. If I add up all of those probabilities, just like if I added up the probabilities in a table, I know the total will be 1. And remember that we're dealing here with a discrete variable. So the value of x, the number of wins or the number of successes, can only be a whole number. And 0 is the smallest it can be, 10 is the largest it can be. Do you always get this symmetrical pattern with binomial probabilities? Well, you do not. If the probability of success is low, the chances are you're not going to succeed very often. So you get a skewed distribution. And we often show this not with bars, but with a sort of a bell curve shape like that. Again, there are probabilities of 6, 7, 8, 9 and 10. It is possible that you win 10 times, even if your chance of winning is only 20%. But it's tiny, very, very, very unlikely. And similarly, if something has a high probability of success, you're likely to get a lot of successes. And you get that sort of shape. And the mode, the most popular result, well, you might have spotted that it's the number of times the probability of success. So we had a mode of 8 here, a most popular value of 2 there, of 2 there, sorry, and a most popular value of 5 here. So we talked about skew before. We see skew in the distribution of probabilities with a binomial probability distribution. And what we were doing with our calculator in our live lesson the other day was we were saying, okay, let's work out the probability of 0 to 4. So what the calculator was doing was adding up those probabilities for us. So we were effectively working out all of those added together. Remember, these are only whole numbers, so it was adding up the probability of 0, 1, 2, 3 and 4. Okay, why have I introduced these graphs to you? I've attached these graphs to class charts, so you don't have to make copies of them if you don't want to. And I've also attached them to the email, and I put them in on the OneNote page where I'm keeping all my remote lesson videos now. So hopefully you can access a copy of this. Why are we doing this? Well, what I want to talk about today are reverse binomial problems, which I'm actually going to call inverse binomial problems. And I'm always going to solve them by starting with a sketch of the shape of the probabilities for that particular problem. Okay, so this is the sort of problem we're dealing with. Here I'm told about a variable which can be modelled using the binomial, something happening 50 times, and each time it happens the probability of success is 0.4. So I don't know, this is me playing Mr. Godbat at golf 50 times, all right? And the chance of me winning is 0.4. It's actually much bigger than that, but anyway, we'll run with it. Now, you know, I might win none of those 50 games, I might win all of those 50 games, but the probability of that's pretty unlikely. We know the most likely answers will be the ones in the middle here somewhere. But I could draw a bar chart like the ones I was showing you a moment ago with all the bars from 0 up to 50. I've drawn this sort of, bell curve just to show the rough idea that you're going to get. And I know the peak will be slightly to the left because the probability is slightly less than a half. Right. Before we answer this question, I'd like you to work out 6 probabilities for you. I'd like to work out the probability that I win less than or equal to 12 games. So I'm hoping that you will put lower of 0 and higher of 12. And what that is the probability of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, and 12 all added together. Calculator does it for us, though. Probability of 0 to 13, probability of 0 to 14. So those are 3 probabilities from down this end. Here, I'd like you to work out the probability that x is greater than 26, which I hope you can see will involve a lower of 27 and an upper of 50. Okay, x can only be a whole number. So if it's greater than 26, it's got to be 27 or bigger. And then greater than 27, greater than 28. Work out those probabilities for me, rounding them to 4 decimal places for me. Okay, sorry, I've added another one in here. Greater than 25, I got that by doing a lower of 26 and an upper of 50. So what I've worked out down this end is the probability of 0 to 12, which I can sort of show graphically. Those probabilities there, remember that's 13 bars all added together, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, is this. The probability of 0 to 13, and this is clearly not to scale, is bigger. And the probability of 0 to 14 is bigger still. In fact, that takes us above 5%. So there's a greater than 5% chance that I win between 0 and 14 games. The question said, what's the biggest value of k so that the probability x is less than or equal to that is less than 0.05? What they want to know is which of these numbers is the last number which is less than 0.05. Hopefully you can see it's 13. So k is 13. The probability that x is less than or equal to k is less than 0.05, 0.028. The probability that x is less than or equal to 14 is bigger. So we've gone too far. So the answer to that question was 13. So in these questions, they give you the probability, and you've got to work out either the lower or the upper. What about the second question? So the probability of that's greater than 28, which is actually from 29 to 50, is a tiny probability, 0.0076. Remember, the probability of getting a head on a coin is 0.5. So this is a tiny, tiny probability. Very, very unlikely. 28 to 50, which is this probability, 0.016. 27 to 50, 0.0314. So the probability is getting bigger all the time, obviously. Not to scale, is this? This is not clearly not to scale. 26. That goes above 5%. So the question this time is, when does it fall below 0.01? Okay, so when x was greater than 26, it was above 0.01. When it was greater than 27, it was above 0.01. When it was greater than 28, which remember we got by doing 29 to 50, when it was greater than 28, it fell below 0.01. And so that's why the answer to that question is 28. 28 is the smallest number, the first number as you get bigger, that gave you a probability of less than 0.01. Now, I make no bones about this. I think this is really hard to get your head round. And of course, I helped you out by giving you the values to sort of hunt around. You wouldn't be given those, would you? So let's have a look at another question, and maybe I'll remove a little bit of the safety net. Okay, so here's a second one where we've got something happening 40 times, and each time the chance of me winning is 0.1. So my peak is going to be really low. In fact, my peak is going to be at 4. I'll tell you that because it's that times that. So it's a very skewed distribution of probabilities. we've got questions to answer here. I'm going to help you out on the left-hand side. Work out those probabilities, see if you can therefore answer part A, and then see if you can answer part B. And I'm going to tell you to start at 7 and work up. Okay. Now, the probability x is less than 1. What are you going to put for your lower and your upper? What scores does that allow? Well, it only allows 0, doesn't it? So this is an odd one. This is going to be the probability. This is the same as saying what's the probability I lose every time. So you're going to make it upper and lower 0. Here, the only score you're allowed is 0 or 1, and here the only scores you're allowed are 0 or 2. So remember, when it's no extra line, you've got to think about what you put in as your lower and upper. This one will be a lower of 0 and an upper of 1. This one will be a lower of 0 and an upper of 2. I'm not going to give you any help at that end, but start with 7 and move up. Okay, so probability x is less than 1 is just the probability of 0. Upper 0, lower 0 gives me that. Less than 2 is just 0 to 1, so it's the probability of 0 and the probability of 1 added together. Less than 3, 0, 1 and 2. And obviously those are getting bigger because you're including more possibilities as you move up. So I want to know the largest value, the last value as you move up, where the probability is less than 0.02. Well, that is less than 0.02. That is bigger than 0.02. So the last value is 1. So k is equal to 1. Here at the top end, we're moving up now, so we're looking at probability 0. And you'll see I've sketched this really, really badly because actually we've got tiny probabilities here. So the probability x is greater than 7, which is 8 to 40, lower 8, upper 40, was that tiny number there. Remember, greater than 7 doesn't include 7. Greater than 8, which was 9 to 40, 0.0155, and greater than 9, it was in standard form, it was 0.0051. So I want the smallest number, so as I move up, getting bigger, the last number that gives me a probability that's less than 0.01. So, is this less than 0.01? It is not. Is this less than 0.01? It is not. Is this less than 0.01? It is. So this is the first value that gives me a probability of less than 0.01. So R was 9. We're then asked to find the probability that x is between 1 and 9, including 1 and including 9, and you get 0.98002. You might say, well, isn't it 1 minus that and minus that? Well, it isn't, because the probabilities weren't exactly that, and they weren't exactly that. But if you do 1 minus this and minus that, then you will get that answer there. But I just did it on my calculator. Now, I realise that this is tricky to get your head around. So don't forget that I said I would on Friday do that sort of clinic live lesson if someone wants to ask to help. But we've also got a bit more of this to come later in the week as well. We're only at Wednesday, aren't we? But let me give you a question to have a go at yourself, and then I will post a worked solution to this tomorrow on Wednesday. Sorry, I'm making the video on Tuesday. I will post it for you on Wednesday when you actually do the video. It starts off with a situation that gives you a binomial where n is 50 and the probability of success is 0.05. Although in this case, success, sorry, I just got a little tickle, success is finding a defective component. So it's perhaps an inappropriate word to use, success. The probability of finding a defective component is 0.05. So that's our probability. X is the number of defective components we find in a batch of 50. So the first two questions are just normal binomial questions with your calculator. You've got to decide what your lower and your upper need to be for those. For C, I think C is a wordy question, so I've tried to help you. There's a point at which the the inspector will stop. He'll say there's too many defectives in this sample. All right. Now that happens less than 5% of the time. So what we've got to do is we've got to find this value here where the probability of every value greater than that is less than 0.05. So like we did in the two examples, you might want to go back and look at them. We're on the right-hand side, so it was the examples on the right-hand side. We're going to try some different values here. Now remember, if you make that equal to 40, for example, then you're actually going to try 41 to 50, aren't you? Because greater than 40, the first value it could be is 41. So you've got to find the value of D. Now I'm going to do a work solution to that one. There's two other questions here that you might want to have a go at. From the mixed exercise, page 96, you just got a normal binomial question, but that's in context, so you've got to sort of derive this from the problem. And then you've got another one of these inverse problems, and I was going to look at that one at the start of Thursday's lesson, so you might want to have a go at that ahead of then. Okay, make no mistake, this second half of the lesson, tricky, absolutely tricky, but there we go, you'll be fine, I'm sure. Take care.